Okay, so now we've had I had the time to check the number of this lemma in the book, which is, happens to be 1.3.8, and this is what's going to conclude this first, lecture, the only lecture that we're going to have this week, because remember that you have an exam. And heuristically speaking, this tells us that the supremum has to be very close to the set, to all the elements in this set. So if you move a little bit, so if you decrease its value a little bit, then there must be elements in the set that are greater than that. S minus epsilon for some positive epsilon. So if you decrease it a little bit, then you will be able to find elements in the set that are bigger than this new number, namely S minus epsilon. And what is a proof? So yeah, so we have an if and only if. So let's do the first implication, the first direction. So if S is the least upper bound, so we already know that this is common for both statements. So we're only showing S is equal to the supremum is equivalent to, for every epsilon greater than 0, that there is an A. It's equivalent to the statement that for every epsilon greater than 0, there is an A in A, such that S minus epsilon is smaller than A. Both statements here on the left and on the right share the same assumption that S is an upper bound. So given that S is an upper bound, on either side you have to show the equivalence of these two statements. So starting from the fact that S is the supremum, we must show that this statement here on the right is true. So we first let epsilon be greater than 0. If S minus epsilon, if for every A in A, A would be smaller than or equal to S minus epsilon, S minus epsilon would be an upper bound for A, right? So if this were true, then S minus epsilon would be an upper bound for A. So picking any element in A, S minus epsilon is greater than or equal to that, then S minus epsilon would certainly be an upper bound for the set A. But but then since S minus epsilon is less than S, S cannot be the least, right? So it cannot be the least upper bound. Because there's a smaller upper bound, namely S minus epsilon. So what we've shown here is basically that not this on the right implies not this on the left, which is equivalent to showing this implication this direction. So what we've shown, so you wanted to show P implies Q, and what we've shown, that not Q implies not P, which is a contrapositive. So this is completely equivalent to that. Okay, so we've shown that if there is an epsilon such that, this is the negation, this is how we negate this. So if there exists an epsilon greater than 0 such that for all A in A, S minus epsilon is greater than or equal to A, or A is less than or equal to S minus epsilon, then S is not the supremum. Yeah, so we've shown that implication, right? We show that by showing that if this and the right were not true, then S would certainly not be the least upper bound. Let's try to show things in the other direction. So what does this mean? So this is the other direction. So I have problem controlling my pen. Okay, so the thing is now that we're assuming the statement on the right, so that for every epsilon greater than 0, there exists an A in A such that S minus epsilon is less than A. And we want to show that then S has to be the supremum of the set A. How do we go about showing that? So remember, the only thing that is missing here is to show that S is the least upper bound, right? S is the least upper bound, right? If not, it's the least upper bound. Assuming for both sides at the same time, that S is already an upper bound. We already know that S is an upper bound. So you want to show that S is the least upper bound starting from the right. So we let B be an upper bound for A, for the set for the set A. Remember, what do we want to show? Keep that in mind. We want to show that B is then greater than or equal to S, because that would complete the proof that S is the supremum of A. We already know that S is an upper bound, so knowing that B bounds in any upper bound bounds S from above would show that the S is in fact the least upper bound. Okay, so B is an upper bound for A. And we're assuming that if we subtract any epsilon from S and there's an element in A, and any positive epsilon, then S minus epsilon will be less than A for some A in A. Given that B is an upper bound for A, it means that B is greater than that. Yeah, so B is greater than or equal to any A in A. Now, so let's assume the contrary, that in fact B is not greater than or equal to S, but that B is less strictly smaller than S. This would imply then, if this is the case, then S minus B would be positive. Right? If this is the case, S minus B would have to be positive. This just comes from subtracting B on both sides here. And so now we're going to let this be our epsilon. This is an allowed epsilon here, because this holds for, the statement on the right holds for any choice of epsilon that is greater than 0. So if this is true, then we set this to be equal to epsilon. So this is going to be an epsilon. And since epsilon is greater than 0, then there is some a in A such that s minus epsilon, which is equal to s minus b, is smaller than A. But this is just equal to s minus s plus b. And so you're concluding here that there is an A in A such that A is greater than B. But then this contradicts the fact. This contradicts the fact that B is an upper bound for A. Because if it were an upper bound, then B would have to be greater than or equal to every single A in A. But there's one A that is greater than B, so B cannot be an upper bound. Not even an upper bound. Now, let's stop here for a minute. I mean, before you ask me, of course I said this as a contradiction, but you could have simply started with a B that was smaller than S and then continue the proof and showing that then if B is smaller than S, then it is not an upper bound for A. Or in other words, if B is an upper bound for S, then that means that B is greater than or equal to S. Again, by contrapositive. So I mean, it's just sometimes contradiction makes it simpler, but here, I mean, the contradiction is not really necessary. Okay, and this basically concludes everything for this week. Good luck in the exam.